Alright, here are perfect problems, 6 solutions for Math 111. Given this mess of a polynomial, I'm basically asked to sketch its graph, but figure out all the intercepts algebraically. So what we'll first do is try to factor this guy out, and we want to do that by finding one rational root. So part A asks us to list all the possible rational roots. Well, rational roots are factors of 12 divided by factors of 2. So the factors of 12 are plus or minus 1, plus or minus 2, 3, 4, 6, and 12. But you could also divide any of those numbers by 2. This is dividing them by 1 here. Dividing by 2, you get plus or minus a half. 2 halves I already have, because that's just 1. 3 halves. 4 halves, 6 halves, and 12 halves I already have. So here's my possible rational roots. All right, part B says test all these guys until you find one that works. Let's start with the ones because those are the easiest. F of 1 would just be 2 times 1 to the 4th minus 3 times 1 cubed minus 9 times 1 squared plus 8 times 1 plus 12, which is 2 minus 3 minus 9 plus 8 plus 12. I don't think that's going to work. This is 20 over here. Kind of too much. 22 minus 12, I think you get 10 here. But whatever you get, the point is that it's not equal to 0. So the search continues. Let's try f of negative 1. The same idea. We evaluate our polynomial at negative 1. And hope we get 0. Let's see, negative 1 to the 4th is 1, so that would be 2. This is negative times a negative gives you a positive, so plus 3. Negative times a positive gives you a negative. Plus 8 times negative, and then plus 12. That's looking promising. Negative 17, positive 17, that equals 0. That's awesome. Negative 1 is a root. So now that we know that negative 1 is a root, in part C here we can factor that root out. If negative 1 is a root, x plus 1 is a factor. So we can do polynomial long division. We can figure out what is x plus 1 divided by 2x to the 4th minus 3x cubed minus 9x squared plus 8x plus 12. To get rid of 2x to the 4th, I need to put a 2x cubed here, because 2x cubed times x will give me 2x to the 4th, and 2x cubed times 1 gives me 2x cubed. And now if I subtract, these cancel out, and I got negative 3x cubed minus 2x cubed gives me negative 5x cubed. And then I repeat, except now I do x plus 1 goes into this remainder. X plus 1, I would have to put a negative 5x squared up here if I want to multiply something by x to get negative 5x cubed. And negative 5x squared times positive 1 is negative 5x squared. So now what I'm going to do is subtract. These cancel out. Negative 9 minus a negative 5 is the same as negative 9 plus 5, which is negative 4. X squared plus 8x plus 12. And to cancel out my negative 4x squared, I need a negative 4x here. That gives me negative 4x squared minus 4x. And again, we subtract. 0, 8 minus negative 4 is 12. Get 12x plus 2. To get rid of my 12x, put a 12 right here. Gives me 12x plus 12. If you subtract, you get 0. That's good news. That means you did things right. So let's see what was asking me to do. Use polynomial long division to factor out the factor corresponding to the root that I found in part B. I have done that. Alright, part D says kind of repeat. In part D I say, alright, so maybe I'll write this down here. What I now know is that f of x is equal to x plus 1 times 2x cubed minus 5x squared minus 4x plus 12 But I need to factor further. I need to factor out this polynomial. So now what I'm going to do in part D, I guess, is I'm going to repeat. I'm going to factor out the polynomial 2x cubed minus 5x squared minus 4x plus 12. And it has possible rational roots. Of factors of 12 divided by factors of 2, exactly what I got in part A. Roots of, maybe I'll say, same as part A. Same answer as part A. So I have to start testing those roots. I can figure out what f of 1 is. See, basically I'd change all the x's into 1s. I'd get 2 minus 5 minus 4 plus 12, which is 14 minus 9, which is 5. That's no good. What about f of negative 1? Well, that would give me negative 2 minus 5 plus 4 plus 12. Again, that doesn't work. This is 16 over here and negative 7. That gives you 9. So the search continues. I guess we didn't even really have to test f of 1, because if it was a root of this, it would have been a root of this, and we already figured out it wasn't. But anyways, let's try a 2. See, maybe I can't do that in my head, or at least it's worth writing out. I guess I shouldn't call these f's. Let's give this a new name. Let's call this g of x. And then this is really g of 1. You know what I'm going to do rather than make that all messy? We'll make this f1 of x. So it's not f of x, but I can just put a little 1 there to make it different. Anyways, that's 2 times 2 cubed minus 5 times 2 squared minus 4 times 2 plus 12. Let's see if that works out. 2 cubed is 8 times 2 is 16. 2 squared is 4 times negative 5 is negative 20. Negative 4 times 2 is negative 8 plus 12. 16 and 12 is 28. Negative 20 and negative 8 is negative 28. That equals 0. That's good news. Now what I have to do is, all right, 2 is a root, so x minus 2 is a factor, specifically a factor of 2x cubed minus 5x squared minus 4x plus 12. So what do I put up here to get rid of the 2x cubed? That would have to be a 2x squared. That gives me 2x cubed minus 4x squared if I just multiply 2x squared times both of these terms. And now I subtract. Negative 5x squared minus negative 4x squared is the same as negative 5x squared plus 4x squared, which is negative x squared minus 4x. To get rid of that negative x squared, I need a negative x here. Gives me negative x squared plus 2x. And I subtract. Negative 4x minus positive 2x is negative 6x. I'm going to get rid of the negative 6x. I put a negative 6 here. And that gives me negative 6x plus 12. That's good news. I factored. Alright, part E. Finish factoring this mess. So what I'm saying here is that I already had f of x was equal to this. But I now know that it's equal to x plus 1 times, I just factored out an x minus 2, and I'm left with 2x squared minus x minus 6. So I have to factor 2x squared minus x minus 6. Looks like I'm going to run a little short on room here, but okay. Maybe I'll cheat. X plus 1. No, I'm not going to cheat. I'm going to show you how to factor this. So I want maybe in a different color. Want two numbers that add to negative 1 for the middle term and multiply to negative 12. 2 times negative 6. Looks like negative 4 and positive 3 are those two numbers. So what I can do here is I can say, all right, instead of minus x, I'll write minus 4x plus 3x. And the hope is that I can now factor by grouping. I think I will be able to. Leave all this stuff alone. And then here, I can pull out from these first two terms a 2x. And I'm left with x minus 2. And to be left with x minus 2, I have to pull out a 3 from these next two terms. And so what that gives me is the factored form of my polynomial. Factor out an x minus 2 from both of these guys. And I'm left with 2x plus 3. Which I can take one step further. I can say it's x plus 1 times x minus 2 squared times 2x plus 3. And maybe I could squeeze a graph in. Won't be the prettiest graph, but little that I do is pretty. First thing, end behavior. Where's our original polynomial here? Degree is even. Leading coefficient is positive. So it's going to go up on both sides. So we're going to kind of go up that way and up this way. Original equation, the y-intercept is a 12 if I make all the x's equal to 0. So put my y-intercept here, call it 12. And then I got roots at -1, +2, well, let's get them one at a time. -1, +2, and then 2x plus 3 equals 0. That happens when x equals -3/2. So I get something like this. And I know that the multiplicity of this root is even, but the rest of them are odd. So what happens with my graph here is it goes through this intercept, bounces off this intercept, and ends up going up here. Maybe I can erase that arrow, though I don't know how. How about I scribble it out? Good enough. So this right here is a very bad picture of my graph, but it illustrates all the key points, so maybe it's good enough. And that is the end of this perfect problem.